I'm good. I'm good. My COVID, it's almost all gone. I should be able to go out in public now. Hi, Kason. Good to see you all. Hey, Jacob. Good morning. Good morning. Hopefully you had a great weekend. Let's see here. This is what I want to do right here. Nope, that's not it. Yeah, there we go. All right. Hey, Cadence, Leandras. Good morning. So let's do a little poll while we're waiting for people to show up. It's a Monday morning, right? Would you rather? HER, A and B. Let's see what you guys think about these. Would you rather never eating fruit again, or would you never eat vegetables again? Hey, good morning, Lonnie and McKellen, Cadence, Catherine, good to see you. Alex and Addison, good to see you too. Riley, all right. So most of you guys are saying vegetables. That's what happens, usually vegetables. How about you, Tony? Let's see who else. We got Jada coming in and Layla here. All right, we got 8 people out of 13 so far. We got 19 now. So how about you, Cadence or Tony? Nope, not going to vote. Most of you guys said vegetables you would give up, or you'd rather never eat those then.
Okay,
How
would you
about
rather give up showering for a month or give up the internet for a month?
a month of nothing, no showering or no internet? Which would you prefer? All right. Good morning, Layla. Let's see. Let's see who else. Hey, good to see you, Tony. Thank you, Ella, Layla, Michaelin. And let's see. How about you, Riley, Natalie, Cadence, Jonathan, Jace, Damon, Alexander. Alexander got in there. Great. Thank you. Thank you. So most of you guys would go without an internet. Would do that. Okay, one more and then we'll get started on today's assignment.
I think Gen Z wouldn't smell great. Would you rather be stranded on a deserted island or trapped in a room?
Trapped in a room or stranded in a deserted island? Doesn't say
Would
how
you
long
rather
though.
know how to drive?
Oops, let's go back there. I accidentally hit this one too quickly here. Deserted island or trapped in a room. Most you guys are saying, let's see who else. We have new people. Anybody in here new? Let's see a lot. We got about 25 people. All right. Looks like most of you guys are saying deserted island. Okay. All right. Let me escape this.
On a deserted island or trapped.
Okay. So what we're doing today is we're going to be talking about isotopes. So here is your guided notes for isotopes. Thanks for everybody that participates on a regular basis. This counts as your bonus for the marking period, which is coming up in 2 weeks. We have 12 days left. Let me turn my light off here. Maybe this will make it a little bit better here. All right, so here is the link to that. Guided notes. I think it helps people get an idea of how notes flow. Here it goes. This is the link for you guys. Here is all right, here is what we're going. Tell me when you get in there, ladies and gentlemen. Tell me when you get in. All right, thanks, Kason. So as long as we're waiting for people, this is the $5 gift card. We've got Ella, Kason, Emily, Madeline, Michaela, Makia, Todd, Ava, and Nicholas B. Those are the people that were doing the TBT practice, and I appreciate that. Those are that got that in there. So let's see who wins this raffle. Nicholas here. Nicholas. Let me see if I make sure. Yep. Okay. So today is Monday, right? Monday. So gift card. All right. I will give him a call and see how he does. Well, thank you guys for participating in those. Appreciate you guys doing that. We'll have another gift card this when we do the post test. So not as many people practicing. Let's go over to this one. Okay. Thanks for getting in, ladies and gentlemen. So as I said, we're going to be talking about isotopes. We're going to be doing some calculations this week. Okay. Let me just show you that daily bulletin. There is a Friday, there's a test for chapter 4, it goes over week 6, 7, and 8. And there's 2 weeks left in the marking period. So you need to be 60% or better for passing. Now, you want to make sure you get the highest grade possible because the semester gets averaged, average grade between the 2 semesters. So if you got a 60%, then the highest you can get is an 80 if you get 100% next marking period by averaging those. So if you get a decent grade, then you don't need to have as high a grade for the second marking period, right? So anything lower than that, you don't pass the marking period. I'm not sure what that means because that's new for us. I guess you could, if you got a 50%, I guess you could get still pass the semester if you've got if you get 100% next marking period, you can get a 75 average. Okay. But if you have a 0% this marking period, and then there's no way, and you get 100% next marking period, there's no way that you can pass the semester. Okay. Hey, Donnie, glad you made it. All right. So this week, if you guys need some help, let me know. I will open up some breakout rooms. I will be here for Win Day this week. I'm much better than I was last week. All right. I can review ions, cations, and anions. Okay. So make sure you're writing these things down, what those are. I can identify isotopes and count their protons, electrons, and neutrons. This is something that people really struggle with. So pay close attention. That's why the guided notes. I will open up breakout rooms or work on after classes, even at 3 o'clock. If you want some help, I can do that. So I know this chapter 4 test is 60 points, so it does count quite a bit toward your overall grade. So doing well on this will help your grade immensely. All right, so key vocabulary: atomic number, atomic mass unit, atomic mass, and isotope. Okay, I can define those. Right. Okay, so here are your notes. You'll see what I have for you. If I'm going too fast, let me know. So just to review, ions, so this is the word you're going to put in your notes. Ions are charged particles that are typically result from the loss or gain of electrons. Remember, we just lose or gain electrons to make an ion, right? Charged particles. There are 2 types. An anion, remember I told you anion, we wanted to, let me get my pen here. Anion I likened to or made an analogy of like an onion, right? It's, very pungent, makes you cry. Gives you negative, you feel negative about things, right? And that means it has extra electrons. Hey, Jacqueline, grab the notes there, if you will. Extra negative or electrons, extra electrons, right? right? So extra electrons, right? So extra negatives. I should probably use my writing pen, see if it's working this morning. And then the cation, what are we doing? The cation, where are you? See if I can draw up here. The cation is positively charged. Remember I drew this picture of a cat? Right, has some paws. All right, so has less negative charge than protons. Okay, the positive charges there are more of than the electrons. Okay, we cannot change the protons to make it more positive because that changes the identity. So cation, so these are the three words you're putting in there. You're putting in ions, anion, cation. So currently, let's take a look at an oxygen example. It's a neutral atom, meaning that it has the same number of protons and electrons. Now that 3 electrons were lost, the number of electrons goes from to, well, it's only 2 electrons lost, 6 electrons. This is unbalanced, therefore it's an ion. All right, so what do we got? 1, 2, 3, 4, 5, 6, 7. Okay, so 6 electrons here. So this is going to be 8 plus charges, right? And then 6 electron charges. So this is going to be a plus 2 cation, positively charged. Hold on a second, guys. I have to log back in. Hate to do that in the middle of things, but it also makes a difference. Makes a difference here. Okay, there we go. All right. I imagine so. Okay, so let's take a look at this next one here. All right, so let me double check to make sure you hear this okay. I got to stop this and start this over again. This is just a quick review of charges. Let's go here.
By comparing the number of protons to the number of electrons, we can determine whether the charge of an atom is positive or negative, and also can calculate the total charge of the atom. For example, if a chlorine atom has 17 protons and 18 electrons, there are 17 positive charges and 18 negative charges. Adding the two results in a charge of -1. The -1 would be expressed as a superscript of the atom. Conversely, if an atom has 24 protons and 28 electrons, there are 24 positive charges and 28 negative charges. Adding the two results in a charge of -4. What is the charge of an atom with 8 protons and 10 electrons? Sir.
Okay, I was trying to stop that, but I
That is
got it.
right. The correct answer is B, -2.
Thanks,
8 positive
Casey.
charges plus 10 negative charges equals 2 negative charges. Now let us look at it a different way. Which of the following is an atom with a charge of -3?
All right, so let me ask you that question here. Let's do this one: A, B, C, or D. Start a poll. All right, so which atom has a charge of -3? 3. Okay, A, B, C, or D? Is it 1 electron and 4 protons, 1 electron and 2 protons, 4 electrons and 1 proton, 4 electrons and 4 protons? What do you think? A, B, C, or D? Thanks, Piper, Emily, Michaelin, Layla. Thanks, Kason, Jacob, Bryce, Tony, Martez, Lonnie. Hey, Tyrese, good to see you. Tyler, Silas, I see that you're here. Peyton, Matthew. Come on, you guys, vote on this one. Jenna, Jada, Delilah, Ava, good to see you. So we've got 17 out of 34, 38, 18. Okay, so looks like we got, right? Most of you are saying letter C, 4 electrons and 1 proton.
Very good. The correct answer is
Okay, let's move on here. Okay, so more in depth here. So if we take a look at this, all right, so I'm going to make this a little smaller here. Let me do that. So I'm going to go to the part, let's do this together. I'm going to make this smaller. And then I'm going to pull out my P table. Okay, and let's take a look at calcium. Okay, so calcium, I click on that. Okay, it is, where am I going to see this? All right, let's just have to do it big. Calcium looks like this. 20 is the number of protons, 40 number of protons and neutrons. Okay, so, all right, so here we're going to do this and fill this out. 20 and 40. Okay, so turn my pen on here. Okay, so we know that there are 20 protons. Right, where my pen? Where is it, the pen? Okay, so I'm going to type this in or what? Here we go. So there are 20 protons. Okay, and to have a positive charge, okay, to have a +2, what do I need? I get equal to, shift +2. How many electrons do I need? How many electrons do I need? So I've got 20 positive charges. Okay. Okay. How many electrons? Okay, so +2. So we've got 20 positive charges, and looks like you guys are getting it. All right. You're going to have 18 electrons. 18 electrons. So 20 minus 18 gives me 2 plus. Okay. So there are 40 total atomic mass units. So this means there's going to be 20 neutrons. 20 neutrons. Remember, atomic mass is protons plus neutrons. Okay, let's try the krypton real quick. Where did my P table go? Okay, P table. Oops, did I say krypton? It's chromium, right? Okay. Okay, chromium has 24 protons, 52 protons and neutrons. Okay, so let's go over here. All right, so 20 protons, 24. So let's write that in here. Twenty-four protons. Okay, and it's 52, so we got to have 24 from 52. Oh, not 25. So that's 8. And then 28. 28 neutrons. So how many electrons do I need here? Publish the poll. Start a new poll. I need to have a +3 or a 3 plus. How many electrons do I need to get 3 plus? Remember, there are 24 protons. Okay, and I want to have a positive charge. All right, so in order to have 24 positive, so we got to subtract. Let's write this in here. Come on. So we need 18, right? It's going to subtract 24 minus 18. Okay, will give us, well, actually we need, I'm sorry, it wasn't 18, it was 21. There we go. Yeah, 18. Not 18. Let's erase these here. So 24, 21, 24 minus 21 gives us 3 positives. Okay, right? So, and now let's give you the information on this one here. So S for sulfur. Let's do this again here. Here we go. Sulfur. They're not showing me all of these. I do not know. Let me do this. There we go. Sulfur 16. All right, so 16. And now this one we need more electrons because we have a -2. Okay, so we had to have 18 electrons, okay, in order for that to work, right? So 16 positives. 16 minus 18 gives me a -2. Okay. All right, so let me give you a second or so. Anybody need more time to copy that down? Nope. All right. Okay, so let's review what we already know. Atomic mass of an isotope. So carbon, this is carbon, has quite a few isotopes. Has the mass, which you remember is the protons plus the neutrons. The atomic number, which is the number of protons, right? So in this particular case, 6 protons which plus 6 neutrons gives me the atomic mass. This is their chemical symbol. It's always capital. If it has a second letter, it's always lowercase. So like in the case of lithium, capital L, and then the lowercase I. Okay, right? Cobalt, capital O, lowercase o. Okay, so a lot of the elements just have single letters, but if they have a double letter, so this is different than CO, which is carbon and oxygen. Right, so here's some of your notes. Okay, what's the difference with these two carbons? Hint, the mass is different, but not the number of protons. Okay, so the number of protons, here's the number of protons, this one, 6 here. The atomic number of protons, 6 and 6. But the neutrons are different. So here are your vocabulary that you're going to put in. You're going to put protons and neutrons here. All right, so the atomic mass, and sometimes they write it in the other order. They write 6 on the top and 13 on the bottom, which is fine. Just have to remember that the larger number is the atomic mass, right? Yeah, thanks, Isabel. You're right. Fe is a good example of that. Iron or carbon in this particular case, as long as it's the larger number, that's your mass, right? So these are 2 isotopes of carbon. This one has 1 extra neutron, carbon 13. Well, there's actually carbon 12, carbon 12, carbon 13, and carbon 14. We're going to look at the notation for that. So isotopes is a new term for you. Maybe you've heard of it. Atoms that have the same number of protons, but different number of neutrons. So look at hydrogen. Hydrogen by itself is called protium. Hydrogen with a neutron is called deuterium, and hydrogen with 2 neutrons is called tritium. Okay, they use these during atomic tests when they were building the atomic bomb. They needed that. I'm not sure if they use them as much these days, but here is the different. And again, the electrons are the same. You see that they all have 1 electron, but have just 1 proton, right? So the neutrons, the only thing that is different about these. Okay, so the atomic notation, what we're going to be looking at. So here's atomic notation when you write the atomic mass on the top, on the upper left-hand corner. You have the symbol oxygen, and then you have the atomic number or the number of protons down below. Okay, both all on the left-hand side. Phosphorus, 31 atomic, that's the atomic mass, the number of protons and neutrons. The atomic number, 15. And then zinc, 65, mass unit, which is protons plus the neutrons, or called the atomic mass, and 30 protons, which is the atomic number. So here is atomic numbers pointed to, mass number 13. And the reason we want to call it mass number versus atomic mass is because if we take that part out, it's less confusing. Okay. So atomic notation, we're writing things down like this, and these are how you identify the parts of it. Okay. So identifying isotope notation. Okay, so another way, so we're taking the atomic notation. Example 12(6)C, or simply just 12(6), 12C. There's a simpler way to write this. We write this as example, we call this carbon 12. We use the mass notation to signify the difference between the different isotopes. Carbon 12 has a mass of 12, 6 protons, 6 neutrons. Gives us only the mass number, hence we call that the mass number. Hence that's the name, the mass number. So carbon, you can write the whole name out, put a hyphen and a 12, or we can just put C-12. Okay, so some more isotope examples. Neon 20, 10 protons, 10 neutrons, 10 electrons. Neon 21, 10 protons, 11 neutrons, 10 electrons. And neon 22, 10 protons, 12 neutrons, 10 electrons. Notice the number of electrons doesn't change, because if they did, it would be an ion. Ions refer to the difference in electrons. The charges, so there's different ways of looking at them. Ions, they can be cation or anion, whether they have more electrons, then they're an anion. If they have less electrons, they're a cation. And the elements stay the same. Isotopes, that's very similar to isotopes. Isotopes stay the same as well. The atom stays the same. The protons stay the same, just like in ions, except for we're changing the neutron, only changing the neutron. And again, these are things that happen in nature. This is what they come at, isotopes. There's a whole variety of them. That's why we average them out, and you get this really strange number that's not a whole number when we're talking about the masses. Okay, so here's an example of hydrogen we've talked about. Here is the atomic notation, where we put the 1 for the mass up on top, 1 on the bottom for the number of protons, or the atomic number. So this is that protium, 1,1. We also write it as hydrogen -1, hydrogen 1. 2, 1, the atomic mass. This has an extra neutron. We call that hydrogen 2. And then 3, 1, call that hydrogen 3. Why doesn't the number of protons change? If you remember, the number of protons, if that is the DNA of the atom, and it would be a different element rather than the same element. So these are all hydrogens. The only difference is they have an extra neutron or two. So here, as hydrogen 2 has one neutron, hydrogen 1 has no neutron. Hydrogen 2 has 1 neutron, and hydrogen 3 has 2 neutrons. Okay, so let's do some problems here. All right, so carbon 11. So the atomic number, if I can use my pen here. Okay, there we go. So here is the number of electrons. Here's the number of protons. So remember, we're going to take 11 minus 6 to get this number. Okay, so what is, publish the poll, C11 neutrons. All right, so 11 minus 6. What do you get? Start a poll. 11 minus 6. What are you going to get? Thanks, Jacob, Kaysen, Piper, Bryce. Bryce, if you need some help, let me know. 11 minus 6. Hey, you get 5. Okay, that's the number of neutrons. And the 0 notation here is the charge, right? Right? And electrons, E minus is the negative charge, and the P plus is protons. Okay, so here we're going to do this one. Okay, for the next one, let's do this one together. Publish the poll. How about carbon? Start a poll, carbon 12. Right? Carbon 12. Start a poll. Right? So we're going to take the 12 for the mass, where I got right there, minus 6. What are you going to get? So 12 minus 6. Yeah, looks like you guys are doing it. So this is 6. Carbon 13, we're going to take the 13 here. 13 minus 6. Publish this poll. Start a poll. So there are a variety of carbons, right? What's this one? 13 minus 6. Okay. Oops. 7. All right. And I'll let you guys do the last one. Okay. Work on this one together. Okay, so we have about 8 minutes left. Okay, so participation on this in-class participation. See how many slides we got left. Okay, so you can finish up the last couple slides there. All right. And write atomic symbols for this one. So you're going to look up what has 8 protons. You're going to write the element here. And then you're going to, so like again, let's say if this was carbon, you'd put the number of the mass number here for A. All I want is A, B, and C. So A, B, and C, these right here. Okay. A has 8 protons, 8 neutrons, 8 electrons. So this is going to be, if this was the case, I would put down 16 and 8. That's what we're looking for here. Okay. All right. Any questions while we're here? Let me know. So here's the definition for the isotope. And then there's an exit quiz. Okay, exit quiz 1. This one's a little bit different in it looks like a quiz. All right. Bryce, you have a question you've got an IDK. You want to meet me in the breakout room and we can work on this together? All right. All right, so I'm going to give you guys about 6 more minutes. Finish up. Any questions, let me know. And we'll be going over this again tomorrow as well. Any questions? Okay. So make sure you submit that for the 20 points, the bonus points. I'm going to double check to see if, let me see, who was the raffle? Nicholas. Is Nicholas here this morning? No, Nicholas. Okay. All right. Won the raffle.